the project that we've submitted for Steel Awards this year is our solar car park. We've actually designed this car park for ourselves with the intention that we're actually generating solar energy for our factories as well as providing shade for our cars in that existing area. So we just go to the next page. So the client was actually Trumod. We did this for ourselves, like I said. We worked very closely with J3 Engineering. They are an engineering firm that specializes in light steel frame construction. And then at the same time, we were also our own main contractor. We did everything from the manufacturing to the installation, design and installation as well. So in terms of the project brief, what we did was we needed an efficient use of space for energy and parking. We wanted to create a covered parking facility that would support the large-scale solar installation while maintaining the functionality of the existing parking area we used. The structure was required to accommodate 710 solar panels across an area of roughly 2,000 square meters. And the other mandate was that it fit into the existing site without affecting vehicle access or the parking capacity. So the final solution we settled on covered 67 parking bays, and it currently delivers around 303 megawatt hours of solar energy each year, which is distributed between 3 factories on our site. And we've had it up and running for about a year at this stage, so we can confirm that it's been performing as planned. In terms of structural efficiency, well, Trumod is one of the largest light steel frame manufacturers in South Africa. So naturally, we selected light steel frame early in the design process, and it offered the structural efficiency needed to achieve the 17.5 meter spans while also minimizing the number of support points needed in the parking area. So in other words, we reduced the column quantity. We were able to space everything out in a way that didn't impact the current parking setup. The other function beyond its structural role, the light steel frame canopy, it also serves as a support system for our solar, but at the same time providing coverage for staff on the site. These are just a few rough first draft renders that were done. The perspectives are all done in-house through Trumod. So these, I'm just going to run through some of the renders. This is actually a very nice one because it's a recreation of the initial photo that we actually used for the submission. So we've got that, and then after that, we're looking at the project overview. So the completion of the project was on the 1st of June, and the total cost was around 6.5 million. That includes the cost for the solar as well. So the type of structure that it is, it's a light steel frame structure, but it also incorporates elements of structural steel, specifically for the columns and the vertical bracing. Feature of structure, definitely innovation. We pushed out our boundaries, achieving the spans that we did. And it's something that we're really proud of. So in terms of sector, we've also put this under the infrastructure as a sort of form, part of energy facilities for solar. The project overview. So the Trumod Solar Car Park was conceived as a forward-looking response to two needs. It was the demand for durable, cost-effective parking infrastructure and the ability to integrate renewable energy solutions into this everyday environment. The intent was to create a structure that not only provided functional shelter for vehicles, but also actively contributed to clean energy generation. Like I mentioned before, that solar that we generate from the structure is actually used on site by 3 factories. So we've achieved that goal. and also the benefit of reducing the carbon footprint of the entire site. We're based in Nuffield Springs, so it's an industrial area. But through doing this, we're actually leading the way in our industrial park when it comes to renewable energy, and it's something again that we're very, very proud of. So by combining the simplicity and technological innovation, the project demonstrates how steel can be leveraged to deliver both utility and sustainability. And from the outset, we faced several key challenges. The car park needed to balance structural efficiency with aesthetic appeal. We wanted it to be something that, if you saw it, it wouldn't look like a traditional, structural steel structure. We wanted it to look appealing. Again, the light steel frame, if the client so chooses, can be cladded. We left ours exposed because we're actually using it as a marketing tool at the same time, so people can actually see the workings of the unit. The other thing that we had to allow for was obviously the weight and the layout of the solar panels as well. So we worked on one panel size, and we obviously with that were able to calculate the loads needed on the dead load side as well as the live loads as well. That allowed us to have spacings on there and walkways needed for cleaning and maintenance. So all of that's been taken into consideration in the design. Light steel frame also gave us the ability to assemble the structure quite quickly, and it disrupted and had minimal disruptions on our site in terms of where the staff had to park. It was a lot quicker than had we done that with any other system. So from a technical and constructor, played a central role in the project success. The light steel frame was designed using our dedicated light steel frame design software. It also is then checked by our engineering partner, J3 Engineering, just to verify that everything has been done in accordance, not just with the SAISC 517 building code, but also as he would be providing the sign-off for council on this job as well. The overall significance of the project lies in its demonstration of how steel can enable integrated future-ready infrastructure. It showcases the adaptability of light steel frame in meeting modern challenges, from renewable energy to rapid urban development. By delivering a structure that's efficient, sustainable, and replicable, the solar car park sets a precedent for similar projects across commercial, industrial, and public sectors. It's not merely a parking facility, it's a symbol of how thoughtful engineering and material choice can transform everyday spaces into contributors to a greener future. The project overview, this is the structural steel work. So again, the project was completed on the 1st of June. The cost of the structural steel element of this build was 500,000. The tonnage used in that was around 8.7 tons, and the profiles we used were H sections, 203 by 203 by 46 kilograms a meter, and we used that was used as the main support for the structure. And then we also used equal angle 80 by 80 by 8 mil, and we used that for vertical bracing between the column bays. In terms of light steel frame, again, project was completed 1st of June. Cost for the light steel frame on its own was 2 million. Tonnage used was roughly 20 tons of light steel frame. The truss span unsupported that we were able to achieve was 17.5 meters. The total structure from end to end is 48 meters. So we were able to divide that up into sections of 17.5, 13, and 17.5. Structural framing. So as mentioned, our structural engineer partner was J3 Engineering, and we also were our own contractor, our own detailer, and our own manufacturer. We do all of that in-house. These are just a few photos that were taken during construction. So once the columns were manufactured and all leveled out on site. They were installed. We then started with the installation of the light steel frame girders on top of the structural H columns. As you can see, once the girders are up, we're then able to start hoisting the trusses up into place and fastening them down. We would do this bay by bay, so that's to avoid adding any additional stress onto the light steel frame. So when I say bay by bay, it was done in 6 meters from column to column. So that is what we would consider a bay. So we would have 3 trusses in a bay, two of them directly on top of the column and one in the center. So we would put up the 3 trusses along with the purlins, the bottom chord bracing and the top chord bracing before moving on to the next bay. That just ensures that that section is rigid and that the team can move on safely and start in the next area. So you can see this section was actually done quite quickly. It was done in less than a week. So you can see how, and this is with the purlin and the bottom chord bracing all included. So you can see how quick this starts going up. This was a photo that was taken on week 3, and all the trusses, all 3 sections are now up. We've got the far left and right, which is the 17.5 free span, which you can see spanning here. And then you've got the center middle section, which is a 13.5 meter section. Fabrication, again, that was us. We did our own. So you can have a look here at, I've just included an image showing, for example, the truss assembly being done in our factory, the type of fasteners that we use, as well as the accessories. And then there's also a few pictures showing how the fasteners are inserted into the light steel frame. And just this section on the side does make note, and I think to keep in mind specifically, look at the differences between this photo, and this photo here. The reason for that is each connection has to be taken carefully, reinforced with multiple fasteners based on guidance from our design software. So as a standard, we use double screwing on all trusses, but where required, our software will actually guide us and indicate where we need to allow an additional fastener. And in areas where there isn't enough space in a cord, we would actually apply a plate and then add those additional fasteners in there, creating the connection that's required for that to work in the way that it should. So the benefits of steel in this application, there's quite a few. So it's in the name, so it goes without saying, strong but not heavy. Light steel frame gives us high strength without bulk of heavy steel. This means the structure can easily carry the weight of solar panels without needing massive columns or beams to support it. Like you saw in the photos previously, it is faster to put up. Light steel frame is quick to assemble because everything's straight, accurate, and easy to handle. It allowed us to spend less time on site. It allowed us to use less labor and obviously less disruption to our staff parking area. The other benefit, and that's a big one, considering that the way that we exposed our car park and our structure in not closing it up underneath, not having roof sheeting, not having cladding or anything on it. The main thing for us is that LSF is galvanized, so it naturally resists rust. And it's perfect for this outer structure that we've built. So in terms of rain, dust, we know that that solar car park is guaranteed to hold up. In terms of cost, steel is sold by ton. So light steel frame will almost always have the advantage over structural steel. So we've actually used a lot less than what we would have needed if we did this out of traditional, portal frame construction. But we did so without compromising on strength. The other benefit of using light steel frame is that the light steel frame profiles are actually channels. So you get C channels, you get U tracks, and those make it really easy for us to actually hide all the cables from the solar installation. Conduits and bracketry, everything was hidden away nicely. So when you look up, you only see the light steel frame and the underside of the solar panels, nothing else. And then, like I also mentioned earlier, the other benefit is that light steel frame gives a nice, clean, uniform look that fits well with this type of installation. And that's it. Thank you.